All right, we are started. Yes, cool. Let's get into this. All right, music technology controllers. These things are opening up all sorts of opportunities for you as a performer and as a creator, whether you're using them on stage or in the studio during the production process. So let's get into them. Why controllers? Well, I got into a little bit about that, but let's get into why controllers versus what we're already doing. So we have these WIMP interfaces. That is a window icon mouse pointer. This is the thing that you're using where you're using your trackpad, or you maybe have an external mouse or something at this point, where you click on things, you move dials and knobs one at a time on the screen. Tactile, like in contrast to that, is imagine having all sorts of knobs and sliders and everything that you're interacting with on the surface of your computer, having a tactile thing that you can touch. So you have like some spatial resolution, like when you're using a piano keyboard. If you move to this side of the keyboard, you're going to get high notes. This side, you're going to get low notes, and you kind of get some of that stuff built into your like muscle memory, so you can do things a little faster. You can do things without necessarily looking. If you're looking at something else that you're controlling, but you're over here controlling it, you can kind of do two things at once at least, which hopefully can make you more efficient as a producer. And as a performer, it's like essential. If you're reading sheet music and playing, if you're kind of checking in with the audience, like if you're in front of an audience, you're mixing something, you're creating something live, being able to kind of connect with them and see them and go, okay, this is connecting, they're ready for the drop, whatever it might be. You can kind of use your eyes for something other than staring at the screen and dealing with the minutia of what's on the screen in front of you. One of the other things about using a controller is that you can kind of perform a track in this is specific for production. You can perform the track in, you can perform it kind of live. There's a sense of improvisation. um, One advantage of the step-by-step is if you don't have that kind of performative skill set, you can enter the notes, for example, one by one. You can program your grid note by note. But for some people who have a musical feel in real time, can sense the tension of the line, how the music's building up and letting down. Live performance kind of feels more musically natural. Um, and you could potentially have more than one performance happening at a time, where step by step you can really only do one thing at a time. Solo production versus group improvisation. This really kind of built on that last idea of you have a whole bunch of people playing together. Like think of the traditional idea of a rock band or something like this. The drummer, the bass player, the guitar player, there's a synergy that happens there that's more than the sum of their parts. There's an energy that builds from like, coming in a little aggressive, a little faster than the downbeat on like the drop to the chorus, like something that, kind of it changes the feel of one player's contribution changes the feel of how another player is going to play in the recording process, which is maybe different than the solo production style where you're making one track at a time and then you make the next track on top of that. It's a really cool process, but that first track doesn't get to react to the second track that you're putting in. Whereas if you're playing in a group and recording together, you could potentially kind of be reacting in real time to how the other person's playing. And in good ensembles, that really can build and create a lot of like amazing energy in the musical process. And the mouse, keyboard, typewriter kind of input process may or may not allow you to do that, at least not on one computer. So this is why controllers, provide an opportunity for us. So let's get into like what controllers. These are some categories that I've somewhat arbitrarily made just to make it easier to kind of wrap my head around what are our options. All right, so we have our tabletop controllers, custom circuits. So I'll walk into what each one of these things are in a little more detail. Tabletop controllers are, anything that you put on the surface and play, touch. Custom circuits really is kind of anything, but I'm going to talk about a couple of specific options that people are using these days. Hybrids, that is something that resembles a traditional music instrument or is built upon a traditional music instrument. Things that are on the body, like things that you wear that become kind of part of you, that it's not necessarily something that you pick up with your hands and manipulate. It's something that's like on you, and your body's doing other things potentially while the controller is doing its thing. Things that are in the air. So this is any sort of controller that you don't touch at all. That you move your body, you move your hands, and the controller is not on you. It's apart. It's apart from you in some way, and that controller then reacts to how you move. And then finally, it's in the hands, something that's not on the table. It's like directly manipulated, ideally using your fingers and thumbs, the things that you really have a lot of neuromotor kind of control over for use in controlling your music. So let's get into like the nitty gritty, kind of the details and examples and these sorts of things. So tabletop, one of our main tabletop controllers, at least in the MIDI and musical world, is the keyboard. This thing is super useful. It builds on hundreds of years of musical theory and history. And a lot of us like actually take some time and learn how to play these things. So right away, it has that advantage for us, that we can use all of our previous musical training right away on the keyboard. Now, you might have like a super like basic keyboard with, like feels like hitting popsicle sticks, or you might have like this crazy high-end weighted keys that actually vibrate as you're playing them. So you really get the feel of the instrument as if it were a real live, piano. Another awesome toolkit are these grids of buttons. Like for this example, I'm using Launchpad, but it's not exclusive to the Launchpad. Ableton has the push. What is it? Native Instruments has machine. There's several other tools out there that are built on this idea of a grid of buttons that kind of break away from the bias that might be created by having white keys and black keys laid out in front of you. Instead of going, oh, I'm going to follow that set of musical rules. If you want to like totally destroy that set of musical rules, boom, these grid button array kind of things do that beautifully. Also, if you're playing, if you're kind of triggering samples or drums or things that don't really like follow musical rules per se, like in terms of their arrangement, the grid is kind of agnostic to how you arrange things. The kick drum does not have to be that lower left-hand corner if you don't want it to be. It could be anywhere on that grid. Whatever like makes ergonomic and performative sense to you as you're creating your music with this thing. We also have like the knobs and sliders. These things are great for doing things like if I'm using a mouse and keyboard and I want to change the volume level of, let's say, 4 different tracks, I would have to fade up track 1, then move my mouse over, click, drag track 2, move my mouse over, click, drag track 3 and 4 and so on. That could not really make sense in musical time. Whereas if I could take my 4 fingers and put them on 4 separate faders and slide them up, at the right exact musical time, that might feel and be the right way to do things. There are some limitations, like there's 4 fingers, but you also have these 2 thumbs, and like trying to get your thumb to line up perfectly with your fingers while pushing a fader, there's some ergonomic challenges. Actually, there's kind of strengths and weaknesses to all these. Let's like take a second and kind of get into this. So keyboard strengths, you got the musical part, it's already there for you. You can think of it as building on all the training. Weaknesses, it's actually the musical part. It might have some bias. How do I spell musical? It might have some bias towards traditional music, and if you're trying to get away from that for aesthetic reasons, or if you're just trying to break a new idea and you just want to like get away from the previous musical theory that you've been using for a different song, maybe that keyboard layout is a weakness. There's also a size factor. A 25 key keyboard, bam, it fits right in your gig backpack. It's only a little bit larger than a 17-inch laptop. But if you have 61, 88 keys or something crazy like this, now you're dealing with something that's like 88 keys. Gosh, I think it's more than 3 feet or a meter long. That's not an easy thing to travel with. It doesn't go in the overhead compartment in an airplane. And if you're thinking about gigging, like doing the airport gigging thing, There's some disadvantages. So the grid, we've got the breaks from music. Let me just kind of get that idea. Breaks from music. Size, these things, at least in the example of the Launchpad, like the Launchpad Mini and the Launchpad Pro, they're pretty small. They're not much larger than your laptop. They will fit beautifully in that gig bag. They could even fit in the seat underneath the seat ahead of you. So if you're thinking about, again, the gigging traveling musician that's getting started, that doesn't have like the tour bus and all of that gack, you're getting on an airplane with probably your instrument. You might be checking some more intense equipment, but at first you're probably going to want to be able to get on that plane with your laptop, some hard drives, some controllers, and go, right? Weaknesses, I didn't get into this too much, but there's a certain simplicity. Some of the older ones do not have what they call velocity sensitivity. So like if you press the button harder, in the more recent ones with velocity sensitivity, you press the button harder, you can get a louder version of the sound, which if you're a really intense sound designer, you might actually use a different sample for a harder press, which could be really cool. So I'm going to say some of that velocity question mark. Other weaknesses, with some of the grids, you only have buttons, whereas some of the push and the machine and I think the Launchpad Pro even has some knobs on it, some amounts of continuous control, because otherwise you just have those, let's say 64 buttons to press. Some of the smaller ones even only have like 16 buttons to press, and that could be limiting in a really cool way or limiting in a really terrible way. Regarding the array of faders and knobs, the advantage is you have all that continuous control. But there's with the fader and knobs, like if you have a fader and a knob that kind of like has a nice feel to it, there's usually like a certain amount of girth of the controller. Like the really budget ones, they don't feel great. They don't feel like a DJ controller with like the nice slide of that crossfader. So that can be kind of frustrating, that the one that fits in your backpack very easily with your laptop might not be the most awesome thing to perform with, but it's better than nothing. So I would say size can be an advantage, and size can also be a disadvantage. Question mark. What else can we think about here? Oh, sometimes with the fader knob devices is that they don't have any push button controls. Like you don't have a way to trigger something. So you don't have a discrete control. Everything's like continuous along a spectrum, which can be awesome. For like fades, you don't want to like hit a button and have things fade up if you're trying to do like a smooth, slow fade. If you're trying to get to like a really tight cut, like a build up to a drop kind of a thing, yeah, that one button, bam, is really kind of satisfying. But like trying to fade between your build up content and trying to land on the downbeat of your drop, with a fade could be tough. I've done it before with MIDI controllers. I'd rather have a DJ, really tight DJ crossfade on that. And I'm sure you can these days probably find a controller out there that has that really sweet crossfade feel. I don't have any great examples of that at the moment, but it's something to look into if you're going in that direction. So let's clear all these. All right, custom circuits. Custom circuits are kind of amazing because you can build stuff from scratch. And this is great if you are on a certain type of budget, like if you've ever played with Lego bricks, you get one kit and it can make, a race car or a space shuttle or something of this nature. And then you get a couple other like kits that can do the thing you got it for. But then you take everything apart and you have all the scrap, all these loose parts that then you can build and customize into whatever you want. There are kits out there that are like much easier to use in the case of the little bits. The little bits just they use these little components that just magnet together. So there's no soldering like you see in this example. You have solder joints all over the place. They actually did something kind of brilliant. They use paper clips and alligator clips. So the individual parts kind of join together kind of quickly and easily, but you still have to do a certain amount of soldering in the process here. The other really cool thing that's out there now is this Arduino system. It's a very lightweight programming environment, a procedural coding. It's not true object oriented. So you don't have to have like a whole lot of code chops in your head. You can just kind of do things like, if this measurement is above a certain value, then do something else. Very, very kind of elegant toolkit with its own kind of technical challenges that have recently been upgraded. So again, let's get into the strengths and weaknesses of these tools. So a little bit, strengths. You have that fast connectivity of the magnets. Weakness, limited connectivity. You pay for that ease with that ease of connectability with the inability to arbitrarily connect every single object to every single other object. There are a couple limitations, like you can't connect a battery right to the same exact terminal of certain things, which you may want to do if you're a crazy mad scientist engineer kind of person. There is a cost factor with little bits, the individual components, $1 or $2 a piece. That price to get something substantial, like to build yourself a pretty substantial controller, you're now looking at the cost of another controller. Like if you're going to spend $300 on a controller, you might want to just buy a finished working controller versus buying $300 of little bits. Might get you a rudimentary controller that could work for you, but it could also just fall apart. It's magnets. Arduino, super cool in terms of flexibility because you're programming the thing from scratch. The weaknesses are the flexibility. If you're programming things from scratch, you are spending time engineering and developing and coding, learning how to code, building circuits and these sorts of things, instead of making music, which, if you're making a tool for musicians to use, that's totally awesome. It's something I've done before, and I really appreciate when other people take their creative energy, their musical creative energy, and build something that then I can borrow, buy, or use to make music on my own. I really appreciate that. But sometimes, like if you're looking to get from right now to having a controller to making music, there are some challenges. The flexibility that Arduino provides creates challenges for you. There is a cool cost factor with any kind of like hand-built electronic circuit like Arduino. You're looking at like a let's say a $30 base unit, and then you spend another $70 on components, and you got yourself a project kit that you could turn into something kind of cool. There are some connectivities. I would say that one of the weaknesses with Arduino is musical connections. Getting the Arduino to communicate MIDI is not a trivial task, whereas there's a new-ish tool, I mean, it's like 10 years old. There's a newish tool called Teensy that is built upon Arduino and allows for direct MIDI connection. So you build a circuit, with Arduino, you had to kind of like, you made your circuit, you made your Arduino code, then you had to do some other steps in code or other steps in terms of system building to get MIDI messages from the Arduino into your music software. That might involve having a MIDI interface, a MIDI to USB interface, which is, adds more cost. Or it might involve doing some like rather tedious programming that then makes your Arduino less flexible, because now the Arduino is kind of like fixed. You can't go back and make little changes. Whereas the Teensy, you can get in there and reprogram it, and it's sending MIDI, it's over USB, so like you don't have another device, you don't have another code base that's doing the translation of serial messages into MIDI. Pretty awesome. Some of the costs with Teensy, just like the Arduino, are the flexibility. and there is some robustness. The TNT does not take the physical abuse that the Arduino takes. It's all surface mounted components. So if you've got a cable plugged into the thing and you're rocking the thing around and the cable yanks on the USB adapter just right, um, it just pops right off. So there is some, I'll call it robustness. You can enclose the TNT. Obviously, it's small enough. I probably should let me mention that the TNT is a smaller form factor, whereas the Arduino is something like this big. The TNT is something like this big, as the name might suggest. All right. So you don't want to necessarily build circuits. For example, let's see what you could do. Let's take hybrids into account. Hybrids are kind of an exciting grouping of musical controllers because you have musical controllers that, like a MIDI keyboard, exist in the style or built in the style of an existing instrument. So let's say you have woodwinds experience, or you play saxophone or something like this, or you are a, what do you call it, like a guitarist or a string player of some sort, or a drummer. There are controllers out there that are built upon those skill sets. It's what would we call it, like a musical metaphor, if you will. So the controller is built to metaphorically play like the other instrument. It's not exact, it's not a perfect one-to-one. You know, some of your key configurations on like certain controllers might feel like a saxophone, even though it holds like a clarinet or a flute. So, you know, there are some compromises, but it allows you to use some skills you already have. We could modify or extend an existing instrument. The big example I use for this is the electric guitar with effects. And then there's the controllerized electronic instrument. So that is, take an existing traditional or electronic instrument and wildly change it by adding custom circuits to it. So let's dig into this, some of the details here. So our digital instruments they emulate existing instruments. So the electronic wind instrument, or EWI, kind of family of instruments, all kind of have some sort of breath module where you're blowing, and you can use your tonguing technique and these sorts of things to play the instrument. This can be really satisfying because you activate a note, and unlike a keyboard is you press the thing and the note sounds, and it usually sounds and then fades. With this instrument, you can blow, start the note, and then you can blow and have the note crescendo, which can be really satisfying, making electronic sounds do that in a kind of musical way where, it has to take breathing and breath into consideration. So it's not just like, like holding and then slowly fading out. This instrument can allow for that sort of awesomeness. The other thing is, like, if you're used to fingering or fretting a string, you have a variety of instruments that build on that sort of mechanical skill set. So you have some way of articulating with one hand, and another in a way of modifying or stopping a string on the other hand. Or you can, with this particular instrument, you can actually trigger sounds, kind of like how like really elite bassists and guitarists, they'll actually trigger a sound by tapping the string onto the fingerboard or to the fretboard. This device can do that sort of thing as well. And then one that's maybe a personal favorite of mine, because I have percussion training, are the digital drum pads. These things are really fun because imagine being able to travel as a drummer with like a small suitcase instead of like, a carload or a truckload of large acoustic objects. You could show up to a gig with this small like device, relatively small, controlling your computer, where you have all of the amazing sounds in the world at your finger or stick tips. Maybe I'm a little biased on that, but I just find that kind of like really satisfying. The idea of like, okay, I'm playing a traditional drum part. Cool. It'd probably be better to hire a regular drummer for this. But if you need someone who can play like a regular drum part and then drop a loop on top of everything with that same musical kind of precision, these sorts of trigger pads are awesome. And I chose this one because it had the example of the foot pedals too. So like, you've got your kick and your hi-hat kind of thing going on. Let's see. Let's dig into the strengths and weaknesses of these things, perhaps. So strength of EWI built on I mean, all of these build on the strengths of your already existing musical skills. So I'm going to skip that part, but I'm going to say I can't spell that word. But let me just do it in notation. You can build up things of this sort. One of the weaknesses I found with the EWI in particular is the cable situation. That can be frustrating for you if you are used to moving a lot, and then you have to kind of keep track of, there's a cable connected to this thing. We can't just, go crazy. We might pull our laptop off the table. MIDI guitar, the biggest complaint that I hear about any of these MIDI guitar type instruments is timing, like the feel of the timing of the thing. So like in a guitar, like, you touch the string and it sounds immediately, like whether it's a sitting string that you then touch to stop, or you touch it and just kind of brush your finger or plectrum against it, you get these like immediate kind of tactile and acoustic feedback of what you have just done. And with the instruments, like people going from a string instrument to a controller, oh, whoops, I put that on strength. I should have, I needed to put that on weakness. I'm just gonna say strengths flex, and weakness is timing and feel. The feel of the thing. So like, a pianist, like, feel is just slightly different because there's a mediation. Like you strike the key pushes a lever, the lever throws a hammer, the hammer strikes the string sounds. Like, while that happens almost instantaneously, there is a slight disconnect between those two things. Whereas touching a string, the string might be vibrating. You feel the string vibrating under your finger as you're touching it or manipulating it. So some people who have gone from string playing to controllers that emulate guitars, this is one of their big points of feedback, that like the reason that it's not wildly successful is X. Now, if you're a pianist who wants to kind of change position and keytar doesn't, float your boat, these MIDI guitar instruments can be a little more, what do you call it? Can have the right feel in terms of performance. Drums, the size factor, man. The portability, size, all the sounds that you could ever play. But again, with drums, you have that the timing and feel factor too, because like, especially if you play hand drums, because just like the strings, your hand approaches that vibrating membrane, and you can feel it. There's an energy coming off of that membrane. So if you're playing different tones on the drum surface, your hands feel where those tones are. Like if you're playing a drum this big versus this big, your hands are going to find the tones in the different areas. The other thing that some people have complained about that kind of depends on how you have configured your whole controller to computer system is timing. So you strike the drum, and it's this very slight timing, but it makes you as a drummer kind of slow down. Like if you're playing in a really large ambient like arena type setting, sometimes it's hard to actually keep your timing, because the reverb of the space makes you kind of want to slow down into the groove of the room. And if your system has latency, like significant latency, you hit the drum and the sound comes out like, a fraction of a second later, like a noticeable fraction of a second. That can be really frustrating especially in the context of traditional drumming, where you're trying to hold down an 8-beat, and do your fills and this sort of thing. If you're triggering samples in grid time, you might not be as concerned. Or if you're triggering like big dramatic smashes and effects and these sorts of things, that like millisecond timing isn't going to make or break your performance, but it's something to keep in mind if you're thinking about using that kind of control experience. Let's clear these off and look at the next option. All right, extended and modified instruments. I already mentioned before the idea of like the guitar and the effects. Like, an acoustic guitar has a certain amount of, what would you call it, amplitude. Like you can fill a certain size of a venue with the sound of an acoustic guitar before you need to reinforce it. Also, the amount of time that an acoustic guitar string will sustain is pretty reasonably physically limited. Whereas an electric guitar with, active pickups and like amazing compression effects and these sorts of things, you can have these incredible sustains on this instrument. So it really changes kind of how the instrument goes from a percussive kind of like pew, pew, plink plonk, as one of my friends calls it, to a more legato, or if you add an additional controller like a volume pedal, now you're looking at an instrument that doesn't necessarily have to have a percussive or rhythmic element at all. And if you go really like through the roof and get yourself one of the EBOs, right? It's a electromagnetic exciter for strings, for ferrous-based metallic strings. You put this thing right next to the string that vibrates it like a bow, which is kind of amazing because you can have a really long sustained note this way without, there's some ways to do like really long sustained notes where you get your guitar really close to the speakers and get the speakers to vibrate the strings without an uncontrolled feedback, but it's basically a feedback loop of some sort. This thing can allow you to do that without the amplitude requirements of speaker to string to pick up feedback loop. Some other cool extensions of guitars are putting the kill switch like into the electronics of the guitar. So now you can do like really severe kind of rhythmic things that were, not really available to any traditional instrument. Like you have your string is sustaining, you have good compression on the string, so like you can get a really long sustain and you cut. You put little mutes in that sustained note with the cut switch. I think there's some examples of Buckethead I might try to show you at another time, where he just pulls that into his solos, like getting this new kind of effect or sound that you otherwise just don't have available to you. So to break away from guitar, there are some other like really cool ways of controlling music, modifying music that are entirely acoustic. One example that I love to use is the glissando head joint. There's a professor at NYU who's invented this head joint that has these two things that touch your cheeks so that you can play the flute and slide the head joint, kind of like what do you call this? A slide whistle. So you can do these glissandi on a flute, which is not traditionally available as a consistent and reliable performance technique. So this guy has done some really cool stuff with this thing. So that's a pretty wildly modified instrument that still actually remains entirely acoustic. So it's not even a controller context. And then one of the most famous ways to modify an acoustic instrument is the prepared piano concept. It was, I think we credit this invention to John Cage, who was figuring out in like the early mid 20th century, he was figuring out ways of getting a lot of sounds in a very performable context using a piano. So he was performing for dance, and they needed things that were not just like traditional piano sounds. And he figured out a way of modifying the strings. He would put like objects in the strings of a piano, like something you don't want to do unless it's a piano you really own. But he would put nails and all sorts of weird little things in there. So he could play little like notes, and then he could play like all sorts of wonderful ruckus noise and sound effects, all through the same interface, the keyboard interface. In a way, it was like the first sampler of sorts, in the sense that not that you would record sounds and play them back, but in the sense that you would have any sound you could desire at the tips of your fingers through the keyboard. So I'm going to skip this slide for now. So controllerized instrument. This is where you take a traditional instrument or an electronic instrument, electric guitar or something like this, and you add controller components. So that it's a mediated kind of thing, whereas the previous stuff was like the sound of the instrument is modified by changing it somehow. Um, in this sense, you are adding specific controls that talk to a computer, that the computer is either modifying the sound of the instrument, or the computer is doing something entirely different. Like, you know, you're playing your instrument as normal, and then your control input affects some other part of the musical output. So a great example of this kind of context is the guitar wing. So it's this little thing that attaches to a traditional electric guitar and gives you a handful of buttons. I think it gives you, there's a little slider thing right here is a touch slider component. I believe there's another one, sorry, another one in this sort of direction. And this model has acceleration. So as you tilt the instrument, that can control things, which is kind of awesome. Let's see, the next example is the K-Bow by Keith McMillan Instruments. This is, you're holding your traditional string instrument, cello, viola, violin, whatever it might be, and then you're bowing with a modified bow that can feel direction of bow, it can feel how you are orientating the bow. It can even be used not touching the instrument, but it's really designed around what can you do to add control while playing exactly as you normally would. You know, whereas the guitar wing, like you're playing the guitar and then you reach over and touch the controller that's attached to your guitar. The K-Bow idea is you're playing, interacting with the controller doesn't change your playing as significantly as some of these other models. Ben Neal made this amazing mutant trumpet where he's got custom circuits added onto the trumpet. He's got an extra set of buttons, he's got knobs, faders, all these things, all strapped to the trumpet. And of course, he often plays with some sort of mute so that he can really tweak the sound of the instrument in all sorts of weird ways. I think this version even has two actual trumpet, what do you call it? Like the valve systems might be two separate actual instruments with one mouthpiece. All right, so let's get into the strengths, weaknesses of these sorts of things. So guitar wing, strengths is you're not modifying your instrument that, I would say it's a temporary modification. You have really discrete controls where you are doing something that is absolutely unique to what you're doing. You know, you play a chord and you want to, you know, tweak the effects, you reach over and you touch the thing. If you're playing a solo and you want to do some wacky like tremolo or you know, what is that thing? It pitches way up, like out of the range of the guitar. That's like absolutely separate from manipulating the string, and it's very precise. Weaknesses are you have to change how you play your instrument to a certain extent. You know, you are modifying, you're adding new abilities and capabilities to your instrument, but it also means like you have to reach away from your strings to go do something. That requires a new set, you know, more rehearsing, thinking about your playing a little bit differently, because, you know, if you have a pedal switch and a change and you got to fit in all these different things. So you're tap dancing and finger tapping and playing your instrument at the same time, which can be a lot. And if you're singing on top of all that, whoo, that is a lot to manage as a performer. K-Bow, your strengths are you play traditionally, you know, which can be awesome for contexts where you have players who don't want to do the guitar wing thing, where they don't want to rehearse this whole new thing. You can actually go, okay, what happens when you play this part and you lean into the, you know, kind of lean forward in your seat? That's going to change the orientation of the gyro inside of that little sensor. Then you, as like a system designer or interaction designer, can decide, okay, I'm going to pick up that change in orientation as the thing that triggers the next action. So their natural performance gestures and timings and all of these things can be used to create some other activity or trigger some other process to happen, and they don't have to re-rehearse brand new things. You can just say, once you've established that that's the interaction behavior, that's what they're going to do, and they can note that on their score or whatever it might be. But you're not asking them to start juggling whole new controls when they've spent 20 years of their life really mastering how to interact with these strings with a traditional bow. That, while its biggest strength, is also a little bit of its weakness, because if you do have someone who's willing to do all of this new activity, they might have a hard time doing like really discrete things. So it's what would we call it? Continuous only. If they want to like really precisely trigger an event, they might not be able to do that so well with a device that really just kind of measures continuous variables. Mutants, the strengths, I would say you get the best of both. In this sense, you get the traditional instrument, the modified musical, whether it's modified musically or acoustically, and you get potentially really custom placements of buttons and these sorts of things. The guitar wing, it fits on the horn, that's where it is, right? If you wanted the buttons to be right between the pickup and the switches on the guitar, like right there, like right at the bottom of your strums, you could pluck a string, strum a string, and then be like your hand is already on the control surface. In a mutant instrument context, like an example is the Robo. I'm calling it Robo Guitar. It's a Moldover product. He actually Robocaster. Sorry, that's what it is. Robocaster. This guy actually put his all these controls in he sawed the bottom of a guitar right off and made a hollow form that's roughly guitar shaped, and put all of his controls and circuitry in that space, so that the controls were precisely where his hand would be when he needed those particular controls. So awesome strengths there. Weakness is development. With these mutant things, you are building circuits from scratch and these sorts of things, or hiring someone to build circuits from scratch. This can be super time consuming. I'm sure Moldover spent more than a year and a half on the Robocaster, and he had help. He had family members who could code, so like he didn't have to code everything from scratch. He really, kind of had some help digging into that sort of stuff. Whereas the guitar wing, which Moldover also helps develop the guitar wing for Livid Instruments, that doesn't really require all that much development. You take this device, you stick it on your guitar. Okay, your hardware part of your component is complete, done. So the software mapping and that's another discussion, that's another project, but the hardware part is done. If you're building a mutant device from scratch, the hardware thing, you've got to build that all from scratch, so that might be not just learning the code of your Arduino and the control system, but you're probably learning soldering. You're learning all of the relatively expensive mistakes of when you have a $30 component and you do something with the soldering iron that's a little goofy, and now that $30 component is absolutely worthless. Start over, right? That can be a painful process. Very rewarding when you do come to fruition on this sort of thing, but there's some time cost in that process. So if you are trying to write songs and perform them with a modified controller instrument, you are now adding time, like production time that you could be using to writing songs, and now you're using it to solder circuits and design these sorts of things. So if you're going in that direction, it's got to be worth it, right? You got to be developing something that will allow you to do the musical things that you really want to do. So I've mentioned Matt Moldover a couple times now. He's kind of what we call the godfather of controllerism. He sort of coined the term, or the term was coined after what he was doing. He did something that I think is worth mentioning early on, where he would take existing MIDI controllers, cut them open, and deeply modify them. He changed the He took the built-in slider heads off and put things that felt a little better to him on there. He glued paddles onto the black keys, so the black key was as wide as the white key in the region where it was. He took he took a bunch of things. Continuous control slider, an XY slider, and put that on. All this thing. This was his sort of Franken controller, which was very satisfying to see him perform. He would do things like this was back in the early 2000s when mashups were like first becoming really big things. So he could like go from the Charlie Brown theme song to like Metallica, you know, kind of seamlessly cutting these things together to like Beethoven's Fifth. You know, he did some modification of the samples so that they could be in the same tempo and the same key, or within not exactly the same key, but within a key that he could modulate to that would make musical sense. You know, he has a music degree as well as a intense focus on technology. After a while, he decided it was time to make a really custom proper controller from scratch. So he made something he calls the Mojo, which is, I believe, available for commercial sale. I've definitely seen it in a couple of guys' studios, like Dylan Lane, aka Lil Gates. He has one of these set up right in the front and center in his studio. As it has a really nice ergonomic feel. You'll notice the button layout kind of fits the hand nicely. You know, you have your thumb and four fingers. Sorry, my drawing skills are so. You know, the curvature of the hand kind of fits nicely on these controllers. You know, for a lot of people, their ring finger and middle finger are higher up than their pinky finger and index finger. So, you know, he's got the sliders and buttons and all that sort of orientated in a way that's ideally very ergonomic. Anyway, if you want to look this guy up, look him up under the name of Moldover. He's a performer, musician, inventor, kind of all-around Renaissance musical genius. So, getting to on the body. So, we've talked about so far like modifying instruments, modifying things that are on the table. Now we're talking about things that you wear so that your movement is used to control music. So one of the more recent products is the Wave Ring. This device allows for, it's got 1, 2, 3 buttons. Otherwise, all the rest of the controls are acceleration and gyro based. So it can detect when you've tapped something. Like if you tap a surface that has a really particular acceleration profile, it detects orientation and like acceleration. Very kind of satisfying controller. Not very deep. What would you call it? In terms of the number of things you can do at the same exact time, but you can make it so this gesture does a filter one time, volume curve another time, a reverb build another time, depending on how you decide to program the controls. There are this is the BioMuse. This device goes on your arm. Atao Tanaka is kind of famous for performing with this thing. And as you flex your muscles, it senses the electrical potential in that flex, in the nerve firings and the muscle firing. Very noisy information, but it allows you to perform by flexing your muscles, which can be very internally kind of satisfying as a performer, but also there's a thing called mirror neurons that fires in people as they're watching someone else make a physical effort. They feel some of that effort. Their brain and body kind of put that together, and they kind of feel that tension. So if you're performing with this tense tension, the audience sees that and they feel that tension. So it's kind of a cool way to connect with the audience non-verbally. A more recent variation on this kind of concept is the X sense, X-TH. So like tenth, but X pronunciation is a little rough on this one. This same idea, it goes on a like forearm or something like this to sense muscle firing, but it senses it acoustically rather than through electrical potential. It's actually picking up the sound of your muscles moving and tensing. Like there's a little bit of sound energy that's going on there, and it's quite easy to measure, and it's a lot less noisy and variable than the electrical potential, which changes when you sweat, it changes when you have different amounts of um, salts in your body and this sort of thing. Whereas the sound of the muscle potential, like if you ever want to know, like take your forearm, put it right up to your ear, making full contact, and flex your hand, make a really strong fist, and let go of it, and you'll hear that ruckus, that vibration, and this device picks that up, and allows you to control it. Again, very very simple controls. It's basically like amplitude, like the more noise, the less noise. Um, but its inventor, Marco Donnarumma, he's put a lot into having that gesture, that very simple gesture, change constantly. So he makes one gesture that's controlling a certain sound, and then the piece is evolving. Now the next time he makes that gesture, it's controlling a different sound, and he kind of coordinates that with the type of movement he's doing. So whether he's making a really hard, kind of point, or like moving his hand in a very sharp, fast kind of motion, this device can pick up those kind of sounds, and if he's programmed his sensor software right, it can detect between those two. So he might be able to go back and forth between these kind of gestures and have it actually trigger things. So in the air, where's the thing? In the air are controllers that sense your body and positions and orientations without contact, and that you don't have to touch them. The oldest and probably most famous one is the theremin. This device had two antennas where you moved towards one, and as you moved towards it, it increased the pitch, and the other, whereas as you moved further away, it increased the volume. So you mute the device by getting your hand very close to the round antenna, and a lot of people perform it right hand on the pitch and left hand on the volume. And this is a picture of Clara Rockmore, one of the most famous theremin virtuosos. She had a violin training in perfect pitch, so she could actually play the device in tune. Whereas most of us humans, when we try to play the theremin, even if you have exceptional tuning in your ears, as you breathe, your part of your body gets a little closer to the antenna, and the pitch goes up a little bit. So you're moving in to hit a specific note, and that note feels about right here, right in this, whatever the particular position is, and then you take a breath, and then you go a little sharp, and then you exhale, and you go a little flat. So you really have to have an amazing sense of pitch. That said, I have heard people play this through an auto tuner, and it's fabulous. So that's kind of the built-in way of playing the theremin. I've also seen a lot of people use it where, okay, you have pitch and amplitude, you have two parameters, right? Send that into a computer, have the computer do some really rudimentary analysis of the signal, and it gets two knobs. So now you have two knobs that you can perform, however you wish. You can walk up to the thing and swipe it and have a really fast knob turn, or you can try to play like really discrete, or you can have things like where you change direction and out, from forward to back or something like this, and that becomes a trigger or something like this. You could do some super cool things with this technology, and it's pretty darn robust too. It's like thermins, gosh, they were invented 100 years ago or so. So it's a robust technology. Some more kind of contemporary 80s and 90s technologies are like laser harps and variations on this technology, where you have some sort of laser beam and some sort of detector. And when you break the laser beam and cause the reflection, the detector senses that there's a break there. So it's just the most simple ones are just on off, right? The beams are all shining, nothing's happening. You break one, okay, you've triggered something, like played a note or something of this nature. There's some speed to that. It can be a very fast response, but also that can be a little misleading, because you can swipe your hand through the laser beam. If the laser beam is like right here, triggered something, and you wanted to trigger a note and have it sustained, but you moved past it. Oh no! Like there is a challenge with all of these in the air technologies of what do you call it? Tactile and kinetic feedback. A more detailed set of laser beams comes in the form of the technologies behind the leap motion and there's a game system, Microsoft Kinect. These devices send out invisible infrared laser beams in all sorts of directions, and then use the reflection data off of that to determine things like hand position, orientation, number of fingers that are sticking up. In the case of Kinect, it's mapping your entire body. So like hand position, proximity, and this stuff is all figured out, calculated within the firmware or the host drivers. So it's giving you pretty cool detailed orientation. The leap motion kind of deals with maybe a little less than a cubic meter, depending on how you have it set up. It's probably closer to a cubic foot of like really precise control, like where I can tell the difference between a pinched thumb and forefinger and separate. It's a beautiful controller for an elegant small space, where the Kinect is more like involves your elbows and wrists and larger muscle movements. The leap is like super tight, detailed around the hands. And then the final kind of in the air technology that I think is the most useful for us in terms of we can get at it right away is camera-based tracking or computer vision toolkits. This sort of technology uses the area you're in right here, or however you set up a camera, and it tracks objects. Like you can hold an object and it can train a slightly square white object. I will track that, and then you can use this object as a controller. There are people who are training cameras to detect hands, faces. If you use these tools like a Snap, how it keeps the eyes of the puppy dog face aligned with your eyes. Sometimes if you move too fast, they'll get a little screwy, but for the most part, it can track your face and figure out where you're orientated and then render graphics on that. What some of these guys are doing, these researchers are putting that sort of tracking sensor stuff, and instead of applying it directly to graphics, they're handing off that controller data to other systems that you can then use to make music. All right, let's kind of break down the analysis of these tools, because there's a lot going on here. So the theremin, I mentioned the strengths of robust. This thing is super historic in the sense of like it's been around a long time. It's a pretty tough electronic instrument. There are some calibration things that I discovered one day when setting up a system. I was like sweating, running around, plugging things in, sweating. I got it all calibrated, perfect. Took a break, went to the green room, came back to the stage, kind of in a calm sense, no sweat. I'm performing, and I'm like, I reach for, there's a certain position I had to hit to trigger something to happen, and nothing happened. I had to take a little baby step forward, and then when I reached, the sound triggered. My sweatiness affected the, what do you call it? My electrical potential, and therefore I was not as easily sensed by the theremin when I had dry skin versus when I was sweaty. So there are some calibration issues. It's pretty simple, which is both a strength and a weakness, and it actually makes its own noises. So worst case scenario, you could use it as a sound maker of some sort. If you've ever heard those old mid 20th century horror movie soundtracks, you would often hear the theremin as that kind of spooky, otherworldly sound effect. Laser harp looks pretty cool. Especially when you have a dark room with some haze, some smoke and theatrical smoke and these sorts of things. You can see the laser beams. It's really kind of neat. Weaknesses are, for the performer, it's somewhat hard to see the laser beams. Assuming that you're in a room with haze where the laser beams are visible, your hand, like, so if over here is the eyeball trying to see things, your hand blocks your own view of the laser beam interacting with your hand. So the audience sees when you trigger something, but you as a performer do not. There are some limitations. There are some newer laser harp inventions that instead of like a single array or the one dimension of control over triggers. It's two-dimensional, so it tracks your hand with some more detail. Um, the leap motion and connect technologies take that grid kind of mentality of like lots and lots of detail of positions and hands, um, uh, through the laser sensor, and they take that to the next level, add some analysis on top of that, and give you really precise body data, um, which is kind of amazing for musical control. And you don't necessarily have to reinvent the wheel. You do have to be a bit of a programmer um, to use these things. You at least need to do some. There's a tool that I think I'll try to show you at some point during the program called Gecko MIDI, and that takes leap motion data and simplifies it down into MIDI controls. So like there's a MIDI, multiple MIDI faders. So like you could have a MIDI fader that is thumb to one finger, another MIDI fader is thumb and middle finger, ring finger, pinky finger, so on and so forth. So maybe you could have it set up where each one is its own fader, or therefore you could control 4 faders at once by doing this, or 3 faders at once by doing this, something like this. But there are some programming and development costs with using something like the Kinect or Leap Motion. It isn't like the theremin in the sense that it's not an out-of-the-box instrument per se. Camera CV, computer vision, super flexible in the sense that you don't need any special hardware other than the laptop that you're probably already using for music performance, right? Or music production. It's like the Leap Motion, like there's some cost to it. Harp, there's some cost to it. The theremin, some thing you got to go buy, or if you're an engineer, you could build one out of circuits. All 3 of those things have like a build cost. The camera, it's already in your device, which is, price point not trivial, but you've already bought that device, yeah? So ostensibly there's no extra cost for using no extra financial cost for using a camera computer vision based tracking system. So I'm gonna say cost with a dollar, can I get there? Dollar sign. Where the cost of computer vision comes in is just like some of the other ones, programming. You are now either developing something from scratch, where it's, you're like looking for shapes or something like this. So now you need to go find a code library that tracks hands or something of this nature, build that into your system. There's some kind of small rudiments that we're going to go into in this program that you can use, like using the contrast. If you have a light source near your camera, your hands might shine differently, might reflect light differently than your background, and any difference, in the reflectivity of your hands, whether if you have you're in a situation where your hands are darker than the background, bam, you can track darkness. If your hands are brighter than the background, boom, you can track brightness. You can use these things to control parameters. Like one of my favorites is using my fingers like this as faders, so I can fade in a bunch of different sounds by moving my fingers in. I could enable on one hand and control on the other, or something of this nature. But just like with the circuits in our previous pages here, flexibility comes with development cost, development time, development investment. But that is something that I think all of us who get into controllers are willing, that's a price we're willing to pay, because we can now do something that our colleagues in competition that are making music with traditional instruments and traditional production techniques, they don't have access to something that we now have access to. Just like, your friends who study for 20 years playing violin, they have a skill set that no one else has access to. It makes them unique and valuable in a particular way. Whereas, if you're developing programming skills, if you decide like, hey, do you know what? Like, I don't like the nightlife, I don't like music or something like that, you can do what a lot of us do, is get a side job as a, coding related worker or developer. It's kind of cool to have like the ability to say, you know what, there's some things about a certain industry I don't want to participate in for a couple of years. Maybe there's some political issues you don't want to deal with, or whatever it might be. If you've taken the time to develop programming skills through your process and building controllers, you have a new skill set that's super valuable for other people. So if you want to have side jobs that are not in the music industry, you have some options. So while there's some cost, there's also some benefit to that investment of time. All right, let's get to maybe my personal favorite, that's why I put it last, is in the hands. So in the hands, I've defined as anything that is not on the table, that is not a traditional musical instrument metaphor or control system, but is something that you hold in your hands, you can pick up, you can put down. It's not like a ring or anything like that you wear. It is something that like I'm thinking of like a remote control, right? A sweet example is the Twiddler. This little guy is a ergonomic mouse keyboard combo. It's a full keyboard encoded in these what is it, 16 or so, 15 or so buttons. And on the top here is an actual mouse controller. So you've got your clicks, you've got your modified clicks, and you've got your XY for mouse control. Another kind of in the hands controller that's widely available are video game controllers that you can then connect to your computer somehow. Some of them you can connect wirelessly through Bluetooth and these sorts of things. Others allow you to connect through USB if you have some sort of adapter to get to regular USB-A. They're kind of amazing for reasons of cost and availability. Like if you're on a gig and you've got a custom built circuit, one of my rules when I was performing with custom circuits was that I always had an extra or a backup plan. If you are traveling and you're playing with video game controllers, who is this guy? Nils Peres Anderson, I think it was his name. He talked me into using video game controllers one time because he could go almost anywhere where the music he was making was interesting, or there was an audience interested in his music. And if something went wrong with one of his controllers, he could go to Best Buy or whatever the local electronics store was and buy another video game controller and be back at rehearsal like within an hour. So kind of an awesome thing there. And then the one is my personal favorite is using a mobile phone or old iPod or something like this as a musical controller. These things have accelerometers built into them. You can actually program the interface on your touch screen to be push buttons that you can then use to navigate your performance or even build instruments out of this. We'll actually go into how to do that in detail in another session. I just find this one probably the most cost effective because almost everyone has one of these smartphones in their pocket. If one gets lost or damaged, obviously you can borrow someone else's or something like this. The financial investment, once you already have the phone, is about $5 in a specialized piece of software that goes on the phone that communicates with your computer through Wi-Fi. All right, let's see if we can break down the advantages, disadvantages. Advantage of the Twiddler is you have mouse keyboard, kind of a remote context. So if you, like for those of you who use Ableton Live, you know how you can map your keys, your ASCII keys, your typewriter keys to trigger things. This device can do that, and it can do so remotely or wirelessly. It's a Bluetooth-based device. So you are limited to a certain extent on the distance you can get from your computer, but you're not stuck to your mouse keyboard anymore. That kind of covers the strengths. The weaknesses, it doesn't have any motion or acceleration-based sensing. So it doesn't do any sort of gesture recognition. So it's really just like some button presses, some mouse movement, click. That's kind of it for its control functionality. But it works out of the box. There is a cost factor. I think it retails for around $300. So that's not a trivial cost for what it provides. Game controllers, relatively cost efficient, widely available. They have some, they've got their buttons, which if you're a gamer, the buttons are familiar, um, the way a keyboard is familiar to a pianist. So, whereas the twiddler, um, if I were to try to type on this, I would have to relearn how to type A, B, C, D, E, F, G, H, and then with other combinations, I get my other letters. Uh, that's not a trivial learning curve. Um, whereas game controllers, if you are already a gamer using controllers of that nature, boom, you're already comfortable with some of the gesture metaphors, like some of them that have, what is it, move forward, move back, move left, move right, and others have like a strafing kind of thing where you're moving to the left but turning to the right. I'm thinking of the first person shooter kind of massive multiplayer kind of games, where you have these sorts of movement gestures. Uh, if you applied that kind of like moving through a musical piece as a metaphor for moving through a video game landscape, your gesture vocabulary is already in your hands. You already kind of know that feeling, what it feels like to move in this way, and you could kind of think of moving through your piece in this kind of context. Some weaknesses, there are some limits on musical control, because like maybe in games, you have certain things that you're doing very quickly and certain things that you're doing continuously, but in music you might be doing continuous and quickly things both continuously and quickly at the same time, and that might kind of be hard to relearn. There's a couple guys in a band called Anamanaguchi that perform with guitars, and they also perform with Game Boys. These guys, like Ari, I think his name was, he really developed the ability to play scales on an up, down, left, right controller. He really got the hang of it, where he could like play as well as I could play on any monophonic instrument, probably better, because I think he rehearsed more than I did. But he could play that up, down, left, right thing as a scale, because he'd have, like, let's say left was C, and he would do left, up and left combined would be D, and then up would be E, F, G. Now the really cool thing was he put, if he put C on left and E on up and G on right, well, those are a very nice 1, 2, 3 musical scale, right? Or musical chord, a triad there. So he kind of taught himself music theory, as he was explaining to me one time. He taught himself music theory by putting important notes on easy to put buttons and passing tones, like the less, what do you call them, less consonant scale degrees on the in-between buttons. It was kind of a like genius moment of insight when he was explaining that to me. Anyway, you know, there's going to be some, to do more traditional music things, it's going to take some more rehearsing. Let me see if I can spell rehearse. So, all right, MIDI control devices, or I'm sorry, not MIDI control devices, mobile computing devices, aka smartphones and these, oops, excuse me, smartphones, tablets, and these sorts of things. Strengths, lots of people have these things. So there's one. Cost, financial cost once you have the thing, $5. Uh, that's something most folks can come up with it as needed. Super flexible, because the touch screen has no physical limitations within this surface area. So you can program sliders, knobs, push keys, toggle switches, these sorts of things. You can program a lot of brilliant stuff. And as always, with flexibility comes programming and development costs. So, whereas some of these things like that are limited, you plug them in, they do what they do, awesome. These things that are flexible, you plug them in, you're not quite done yet. You still have to build some stuff. The building of the code, the control system for the mobile devices is it trivial? Technically, it's trivial. Design-wise, it's not trivial. But in terms of getting started, there are also templates that are already built. So you're not building things from scratch if you don't have to. There's a lot of really powerful tools that already exist. Um, I think for our workshop, we'll use some templates that you can then modify as you wish. I found that a lot of people, once they find a template that feels nice in their hands, like they've got a layout that makes sense, boom, they're done programming on this device. Now they're just worried about how they use the thing, which is the same as a controller that you get out of the box. You might map that thing differently for different pieces, but it's a relatively, you're in a musical space at that point rather than a purely technical space, which can be kind of, what do you call that? Very fastly rewarding, instant gratification, not quite instant gratification, but it's close to that, where you have a musical vision, you have a way to control it, you do a little bit of technical work, and then you're off and running in a musical direction. All right. If you are interested in digging deeper into this stuff, there's a couple really cool sources out there. One of them is the New Interfaces for Musical Expression Conference. All of the proceedings for the last 17 years or so are on the website nime.org, and it's pronounced Nime as in rhymes with time and dime and other words that are spelled this way. All sorts of amazing research. It's some of the stuff can be like super technical. So if you're needing to dig into, well, how do you do this sort of technical thing? There are sources within those papers that can be useful. It's also a fun inspiration. Another example is the Guthman Musical Instrument Competition at Georgia Tech. This is a really cool thing because whereas it's not showing off research papers, it's showing musical examples. And it's not just limited to controller-based things. They're like the winning instrument design a couple of years ago was purely acoustic. It was like this crazy device where you bowed a string and there was springs in the thing and it created echoes and reverberations, and it was absolutely amazing. No computerized electronics involved in the thing. It was acoustic. It was brilliant. But there are some really cool controller ideas that you can see in the competition. And because it's a competition, you sometimes get people from different contexts. So like NIME is mostly researchers. So like PhD students, PhD researchers, these sorts of things. So the content is very researchy based, and that may be off-putting depending on how you feel about that kind of context. The Guthman Instrument Competition has researchers. It also has industry people, people who are making like products that are out there in the market already. And it has like artist experimenters, people who don't fit in either of those normal, what do you call them, like economic categories of someone who's paid to do research every day, all day, and people who are making money off of existing products that may not necessarily be taking huge risks. Whereas the experimental artist might be willing to take an absurd risk that isn't going to be relevant in a research context and maybe isn't going to be relevant for selling to other people, but might be an amazing thing for making incredible art. And for that reason, I find the Guthman Instrument Competition worthy of review. All right. With that, I think we'll close up this section of the discussion. We might have some quiz review material for you to check out later, because we went over a lot of things and a lot of things that you might want to touch upon. We're probably also going to provide some way of seeing video examples of some of these tools, because like my brief discussion of each of these devices might not give you exactly the big picture that you need to go, okay, is that something that's worth my technical energy to develop a skill in that area? You might find that you'd rather write songs linearly with notes in your DAW than program them manually. But anyway, I want to give you that opportunity as best as possible. We'll also be doing 2 brief technical workshops, one on the mobile computing device and one using the camera tracker. Uh, so with that, see you next time.